Hello and welcome to this video in conjunction with a remote learning task. If in fact you found your way to this material via Google Classroom, be sure to follow all the directions listed there. In this video, we're going to be talking about literal equations and literal equations where we say the students will solve literal equations. So plan on getting a letter by itself. That falls under the solve an equation kind of mentality. Okay. And you will use the properties of equality, such as adding the same thing to both sides, dividing both sides by a number, multiplying both sides by a number, what have you. Okay? So, what are literal equations? Well, literal equations, here's some examples of them before we get into this, sort of taking some notes. If you notice, they are variables that have, equations that have multiple variables in them. They can be formulas, okay? They are very common in science that you'll have to manipulate different equations different ways, okay? And this is a practice giving you the skill set to be able to do that, okay? So let's get going. So a literal equation. Literal equation is an equation with multiple variables, okay? And that is just sort of a working definition, okay? That's plenty of good enough definition for you to be able to work in this topic, okay? So when we do these examples, you have to be told which variable to solve for, okay? So in this first example where it says solve for r, okay, that is here, that means get r alone. We see that the equation is already solved for another variable. It's solved for v. It doesn't have to be already solved for another variable, okay? So here, we're going to get r by itself, which means we need to somehow cancel off the 4/3 and the pi and the cubed. So I'm kind of planning and scanning there for that, okay? Well, I'm going to get rid of the 4/3 first, and a lot of you would probably think, oh yeah, I'll divide by 4/3. If you see on this left side, it's very messy to do that, okay? So better strategy, okay, to adapt in many of your equations that you're going to be solved is multiply by the reciprocal. So I'll multiply both sides by 3/4, okay? It means the 3's cancel and the 4's cancel by way of greatest common factor rules. And that gives me on my first line, 3/4 v is equal to pi r cubed, okay? So now I will divide by pi on both sides. And you see I sort of get the same mess, right? Okay, so instead of doing that, I can multiply by 1 over pi on both sides, which allows me to sort of visually plan a little better on the left side of the equation, which is going to give me 3v over 4 pi is equal to r cubed. And now the only thing I need to do is get rid of this exponent of cubed. And that begs the question, what undoes cubing? And that, in fact, is cube rooting. So I will cube root both sides, and that will cancel the cubing, which then gives me r equals the cube root of 3 times the volume over 4 pi. This, in fact, was the equation for the volume of a sphere. So if, in fact, you had the volume, you could find the radius. The way it was set up before, you needed the radius to find the volume, okay? So basically, they are the same equation. They are just manipulated and reshaped a bit so that I solved for the particular variable I wanted to be solved for, which was r, okay? So next, we have example 2 and example 3. They're the same equation, but I'm going to solve for a different variable in each one. Okay, in example 2, I'm going to take this equation, which is the area of a trapezoid, and solve for base 1. Okay, and in the second example, I'm going to solve for the height. Okay, So the thing, if I'm trying to get base 1 alone, okay, I'm going to need to get rid of the half, the h, and the b2. So I'm going to attack getting rid of the half first by multiplying by 2. And that's better than dividing by half. Okay, so that's going to give me 2a is equal to h times the quantity b1 plus b2. Okay, still focused on solving for b1. I'm going to divide by h. Okay, which is going to give me 2a over h is equal to b1 plus b2. Now for that, I'm going to get b1 alone in one last step by subtracting b2 from both sides because it's adjoined to the b1 via addition. So I'll cancel that off with subtraction. That gives me 2a over h minus b2 is equal to b1. And I've solved for b1 in that I've gotten b1 by itself. Okay? So now, in the second example here where it says solve for h, okay, it means I'm going to have to get rid of the b1 and the b2. And I kind of think of that as one thing intuitively because it's grouped together as a quantity, okay? And I'm getting rid of both of them, okay? And I have to get rid of the 1/2. So I will get rid of the 1/2 by multiplying by 2, which is a nice first step to sort of clear out the fraction. So that gives me h times b1 plus b2. And now to get h alone, I'm going to undo this multiplication here with division. And I'm dividing by the whole quantity here, which is b1 plus b2. Okay? That is going to give me h equals 2a over quantity b1 plus b2. Okay? So, goal in doing this is to solve an equation that has multiple variables for any given variable that you wish. It has to do with the properties of equality in terms of working backwards, and you usually have to strategize and use good order to do so. One of the things that we noticed in these problems with fractions was to use the reciprocal cleverly instead of doing division. So when you divide by something, it's the same as if you multiply by the reciprocal. So that is something that is really comes in handy in literal equations. It comes in handy in a lot of places in mathematics. I suggest you experiment it with it and make it part of your repertoire in solving equations. So I hope this was a help for you in terms of solving literal equations. Enjoy.